Okay, this sheet is about piecewise limits. I have a couple piecewise graphs here. So what we're going to do is we're going to graph these and we're going to see if we can determine the limit. Maybe we can find some holes or something like that. So I'm going to take a couple different colors and I'm going to graph them. So the first one here I'm going to graph in black. X minus 1 for x less than or equal to 2. So I'll go to -1, put a little dot. That's up 1 over 1. And I'll draw my graph in. Just like that. And that chunk, I want all x values less than or equal to 2. So I go to 2 on the graph. I go up to the graph, and or equal to will be a solid dot. And I want less than or equal to. I want all of that part of the graph. I don't even want the other part, so I'll even erase it. The other part, 2x minus 3, I'll do in red. And I want for all x's less than or equal to 2 on that one. Or greater than or equal to 2. So I'll go down to 3, I'll put a little dot. Y-intercept -3, and then it's up 2 over 1, up 2 over 1. That one will be an open circle, up 2 over 1. And on this graph, I want all of that part. So that right there is the piecewise graph for f of x. And I think when I do piecewise graphs, what I'll generally do is I'll try to draw a picture of it so I can look at it. Okay? Now, this problem wants the limit of f of x as x approaches 2. So I'm going to go to 2 on the graph. And I'm going to ask myself, do I get that thing where they come together? And if I do, my answer is how high up are the two graphs? So anybody have an answer for the limit as x approaches 2? I'm at 1. As x approaches 0? Answer is? -1. And as x approaches 10, I'm off my graph. So maybe, since I'm off my graph, maybe I could take the 10 and plug it in somewhere. Could you give me a color as to which color you think I'm going to plug it into?
Red.
Probably red. Look, the red graph extends on out forever. 10 is greater than 2. So if you can't use your graph, you could simply take the 10 and plug it in. So go 2 times 10 minus 3. 20 minus 3 is 17. There are your answers. Okay, let's do the same thing with this one. A little bit more complicated graph, but we can find them nonetheless. All right, so 4 minus x squared. I'll do that one in black. And I don't really like how that's written, so I'll write it as -x squared plus 4. 4 units up, upside down parabola. Upside down parabola, 4 units up. So we'll go 1, 2, 3, 4. It's 1 by 1, 2 by 4, 1 by 1, 2 by 4. And my picture would look something like this. I want all x values less than or equal to 1. So I'll put a solid dot there, and I will color in that much of it. I don't actually even want that part of it. The other one, I don't like how it's written either. I will change the way I write it. -x plus 3. So it has a y-intercept of 3, down 1 over 1 multiple times. And for that one, I want all x's greater than 1. So I put an open circle on 1, and everything greater than 1 would be everything this way. And once I have the piecewise graph drawn, I can find the limits. All right. What's the limit at -10? Here, boom. Where would I be at? Can anybody look at it and tell me? Anybody do the math in your head?
13.
Nope. Square it.
7.
I'd plug it into the black hole. I would do 4 minus -10 squared.
I guess now's a good time to say that it hasn't been recording.
It hasn't been recorded? You're kidding. You're lying to me. Nice try, Pope.
Get pranked! The camera right there!
It's recording you.
4
It's been recording for 5 minutes now.
100 is -96. F of x and negative 10 is negative 96. Okay. What's the answer at 1?
3.
What's the answer at 1? Nope. The answer at 1 is not 3.
Are you kidding me?
Does not exist. They do not come together. At 1 does not exist. What's the answer at 2? 1. And just to make sure we understood the one-sided limits, what is the limit as x approaches 1 negative? And what is the limit as x approaches 1 positive? The limit as x approaches 1 negative says, approach 1 from the left, I'm 3 up. This says, approach 1 from the right, I'm 2 up. And the fact that those two aren't the same tells me that there's no limit at the point.